Have you ever wondered if time travel is possible, or is it just a figment of our imagination fueled by Hollywood movies? Now, that's a question that has tickled the minds of many for centuries. We've all seen it in films, read about it in novels, and daydreamed about what we would do if we had the power to traverse the timeline. But is it just a fantasy, a piece of science fiction, or could there be a glimmer of scientific fact in there? For most of us, the concept of time travel is firmly placed in the realm of fantasy, alongside unicorns and wizards. It's a fascinating idea, one that has fueled countless adventures in literature and on the silver screen, but surely it's not something that could actually happen in reality, right? Well, believe it or not, some of the brightest minds in the world of science and physics might beg to differ. You see, when we start to delve into the complex theories and principles that govern our universe, things begin to get a little strange. Concepts that seem like they should belong in a science fiction novel start to become plausible, even probable. Take, for example, Einstein's theories of special and general relativity. These revolutionary ideas introduced us to the concept of time as something flexible, something elastic. According to these theories, time is not a constant, but rather it's dependent on speed and gravity. The faster you move, the slower time passes for you, relative to someone who is stationary. This is known as time dilation, and it's a concept that has been proven on a subatomic level. Now you might be thinking, that's all well and good, but what does it have to do with time travel? Well, it's quite simple really. If time can be stretched and compressed, if it's not a fixed constant but rather a variable that can be manipulated, then theoretically traveling through time might not be as far-fetched as it sounds. In fact, some scientists even believe that they know how to build a time machine, stating that intense speed is the key ingredient. The idea is to travel at nearly the speed of light, which would cause time to slow down significantly for the traveler, essentially propelling them into the future. Let's delve deeper into this concept and explore the story of a real-life time traveler, cosmonaut Gennady Padalka. In 2015, a Russian cosmonaut named Gennady Padalka broke the record for the most cumulative time spent in space. Now hold on to your seats, folks, because this is where things get interesting. Gennady Padalka, a highly decorated space veteran, was no stranger to the cosmos. He embarked on 5 separate space missions, spending a staggering 879 days orbiting our planet. That's more than 2 years of his life in zero gravity, gazing down at the Earth from the International Space Station. Now, according to Einstein's theory of general relativity, Padalka's extended stay in space had an unexpected side effect. He experienced time dilation. In layman's terms, he effectively became a time traveler. But don't imagine him in a flashy DeLorean whizzing back to the future. The reality is far subtler, yet no less fascinating. You see, Einstein's theory of relativity postulates that time doesn't tick at the same rate everywhere in the universe. It's elastic, flexible, and it's influenced by both speed and gravity. As you move faster or find yourself in a stronger gravitational field, time actually slows down. This is not science fiction, folks, but a fact backed by rigorous scientific evidence. And this is precisely what Padalka experienced. Orbiting Earth at a speed of approximately 28,000 kilometers per hour, time for him moved slightly slower than for those of us on the Earth's surface. How much slower? Well, when he returned to Earth after his cumulative 879 days in space, he was technically 1/20th of a second into the future compared to his Earthbound counterparts. Now, a 20th of a second may not seem like much. We blink and it's gone. But the fact that we can measure this difference at all is mind-boggling. It's a testament to the power of human curiosity and our relentless pursuit of knowledge. So, in a sense, Padalka did travel into the future, albeit by a fraction of a second. But this small step for a man could potentially be a giant leap for mankind. It proves that time travel, at least in one direction, is not just a staple of science fiction, but a tangible reality. If you think about it, Padalka's experience brings a whole new meaning to the phrase, "Time flies when you're having fun." And if that doesn't make you marvel at the wonders of the universe, I'm not sure what will. So what exactly is time dilation? And how did it affect Gennady Padalka? This is where things get a bit sci-fi, but stick with me. At the heart of time, dilation is Albert Einstein's theory of relativity, which comes in 2 parts, special and general relativity. Special relativity, in the simplest terms, tells us that time and space are intertwined in a 4-dimensional structure known as space-time. Now imagine space-time as a sheet of rubber. When nothing is on it, it's flat. But if we put a heavy ball on it, like a planet, it bends and warps the sheet. This is the concept of general relativity, which states that massive objects cause a distortion in space-time. So, how does this relate to time dilation? Well, according to Einstein, both speed and gravity can affect time. The faster one moves, or the closer one is to a massive object, the slower time appears to pass for them compared to someone who is stationary, or further away. Consider this. If you were to take a clock and zoom around in space at nearly the speed of light, when you return, you would find that less time has passed for you than for people who stayed on Earth. This isn't because your clock is broken, but due to time dilation. It's like a cosmic version of the saying, time flies when you're having fun, but with less fun and more physics. This is what cosmonaut Gennady Padalka experienced during his time in space. The high speed of the International Space Station, combined with its distance from Earth's gravity, caused time to run slightly slower for Padalka compared to those of us on the ground. So, time dilation is not just a theoretical concept, but a phenomenon experienced by astronauts like Padalka. It's a mind-bending reality of our universe, where speed, gravity, and time are intricately connected in ways we are still striving to fully understand. Now that we've established time travel isn't entirely fiction, you might be wondering, can we build a time machine? Well, the possibilities are certainly tantalizing. Real astrophysicists believe they know how to construct one, with intense speed being the key ingredient. Einstein's theories of special and general relativity provided the foundation for this, introducing the notion of time as elastic and dependent on speed. Moreover, the speed of light is the ultimate speed limit, and even gravity affects the flow of time. However, making these theories a reality is not without its hurdles. The engineering challenges that accompany the construction of a time-traveling spaceship are immense. For starters, we would need to harness highly efficient antimatter fuel. This is a type of fuel that, in theory, could provide the immense energy required to propel a spaceship to nearly the speed of light. Yet the challenges don't stop there. The safety of the human cargo, that is, the brave time travelers, is of paramount concern. At near light speeds, even the tiniest speck of dust could have a devastating impact. Plus, the effects of time dilation and the physical toll it could take on the human body are yet to be fully understood. While time travel has already been observed on a subatomic level, sending humans into the future is an entirely different ballgame. It's a bit like knowing how to bake a cake in theory, but not having the oven to bake it in. We know the ingredients we need, but we're still figuring out how to put them together and cook up a functional time machine. Despite these challenges, let's not lose hope. The possibility of building a time machine is not impossible. It's a gargantuan task, no doubt, but it could very well be the world's next scientific mega project. This journey of time travel is a testament to human curiosity and our relentless pursuit of knowledge. So even though we're facing a mountain of challenges, who's to say we won't reach the peak? After all, every great journey begins with a single step. Despite these challenges, the possibility of building a time machine is not impossible and could be the world's next scientific mega project. So, where does this leave us in terms of time travel? We've delved into the fascinating story of cosmonaut Gennady Padalka, who by virtue of spending a record-setting amount of time in space, experienced time dilation, essentially becoming a time traveler according to Einstein's theory of general relativity. We've also explored the reality of time dilation, a manifestation of the elasticity of time dependent on speed, as outlined in Einstein's theories of special and general relativity. Moreover, we've touched on the immense challenges of building a time-traveling spaceship, needing highly efficient antimatter fuel and a way to ensure the safety of human cargo. Yet despite these hurdles, the possibility of constructing a time machine is not impossible and could very well be the world's next scientific mega project. Perhaps in the not-so-distant future, we may not need a DeLorean to travel through time. Stay curious, keep exploring, and remember, the future is closer than you think.